With Clelland Maths today, we're going to do the whole straight line in National 5 Maths. That is using the formula y minus b equals mx minus a. If you're given the gradient, you can just go straight away, or using the gradient formula. See my previous video on that for gradient. And we're going to identify the gradient and y-intercept from various forms of the equation of a straight line. We're going to look at equations of a straight line in context, specifically scatter graphs quite often. And then we're going to use the equation of a line of best fit to find some information. Let's just start straight away. So here is basically a straight line, and I've put some 2 points on it, 0, 2, and 3, 5. Now, the first main thing you need to know about the equation of a straight line is its standard form is y equals mx plus c. It's not the only form, but it is the standard form. And m stands for the gradient, and c stands for how it cuts the y-axis. So if I look at this question here, I already know where it cuts the y-axis. It cuts it at 0, 2. So straight away, c is actually the number 2. So the only thing I'm missing is the gradient. So to find the gradient, remember, y2 minus y1 over x2 minus x1. So I pick a point x1 and y1, and I call that x2 and y2. So I've got 5 minus 2 on the top, and 3 minus 0. So I've now got 5 minus 2 is 3, over 3 minus 0 is 3. So my gradient equals 1 for this particular question. Now, what does that mean? It means that the equation is y equals 1x, and plus c is where it cuts the y-axis, so plus 2. So I now know the equation of a straight line is y equals x plus 2. And if it had a negative gradient, it would slope the other way. And you might be wondering, well, wait a minute, what if I don't know c? Can I still do it? Well, you can, because you can actually use a new formula, y minus b equals mx minus a. Now, I'm not going to prove this formula for the purposes of this video. I'm just going to use it, and this is the one I'm going to use all the time. So if I know the gradient, a and b is a point, I can just sub into this, and you'll see that in the next example. Okay, so example 1. The point 2 minus 3 lies in a straight line with gradient minus 4. Find the y-intercept of this line. So we're just going to start straight away with, if you're finding the y-intercept, y equals mx plus c is our initial condition. And I just sub in everything I know. So y and x, well, do I know y and x? Well, yes, you do. Remember, a point is always an x and it's always a y. So my y is minus 3, my m is minus 4, times my x is 2, and I've just got plus c. So now I've got one thing that's missing, so I can find c. Minus 3 equals minus 8 plus c. So that means that minus 3 plus 8 equals c. So c equals 8 minus 3, which is 5. And hopefully you've noticed my backdrop here, a little bit of Halloween, because it's near Halloween when I'm filming this. But let's go to a message from our sponsor now. This video is sponsored by Lecky, and they are offering viewers of this channel 30% off of any of their books. All you have to do is use the code Clelland Maths, and the link to their books is down below. Now let's look at a couple of their books to highlight. We've got National 5 Maths and Higher Maths, and these are complete revision and practice. 2 books in one. We cover the whole course. Here's a random page, for instance, working simultaneous equations algebraically. You can see how good that book is and how clear it looks. But also at the end, practice exam papers that look exactly like the SQA exam papers that are published. Discount code Clelland Maths. Click the link to order now. Okay, welcome back. Example 2. The point minus 3, 4 lies on the straight line whose y-intercept is minus 11. Find the gradient to state its equation. So again, we've got an x and we've got a y, and the y-intercept is our c. So we can use y equals mx plus c. And this is about the only time I would use that unless I knew the y-intercept. So I put my numbers in. 4 equals our gradient, which we don't know, times minus 3 though, plus c, which is minus 11. So tidying that up, that's minus 3m minus 11. Add 11 to both sides. So 11 plus 4 is 15, equals minus 3m. So our gradient is 15 over minus 3, which is minus 5. And we're done there. Getting the meat and potatoes of this, example 3, find the equation of a straight line with gradient 2 through the point 3 minus 1. Just stop there to mention that these examples are all from maths.scot, an excellent website. Get yourself on there to go through topic by topic by topic. So find the equation of a straight line, gradient 2, passing through point 3 minus 1. Now I could use every single time y equals mx plus c. And the reason I'm not going to do that is because later on in higher maths, or when there's fractions in the gradient, it's easy to use another formula. And the formula I'm always going to use is y minus b equals mx minus a. Now it's the equivalent, it gives you the same answer. And A and B is just a point, and our gradient is our gradient. So we just call this A and this B. So I've now can sub into this equation, y minus b minus minus 1, watch out for that, equals m, which is 2, x minus a, which is 3. Minus minus, because there's a minus in the question and a minus in the actual coordinate. Y plus 1 then is 2x minus 6, because I'm expanding the bracket. And then just move the 1 over. 2x minus 6 minus 1 is minus 7, and we're done there. Another example like that, find the equation of a straight line with gradient 3/4, passing through the point minus 2, 5. So that's my A, that's my B, that's my M. Y minus B equals mx minus A. Subbing in, y minus 5 is 3/4 x minus minus 2. Now I'm going to tidy that up first and show you how to deal with a fraction now. So I've got x plus 2. I don't want to expand this because I'm going to get a nasty. I might actually simplify it to something nice, but in general, I'm just going to take the denominator and put it on over here. And that means I'll have 4y minus 5 on the left as the numerator, which is 3x plus 2. And that gets expanded both sides. 4y minus 20 is 3x plus 6. And then moving the numbers, I've got 4y equals 3x plus 26. Now you could at this point divide by 4, and you might have to do that if you sometimes have to find the gradient or anything else. But what you can actually do is just leave it as y, multiples of x. So I'm going to move the x over, minus 3x plus 4y equals 26. Or you can write it as minus 3x plus 4y minus 26 equals 0. xy number equals 0 or xy equals number. Just don't write something like 4y equals 3x plus 6. That's deemed to be unsimplified. You have to have the y's and x's on the same side. That's actually called the general equation of a straight line, but we'll get to that later in the video. Example 5. Find the equation of a straight line through 1, 7 and minus 1, 3. So this time I'm not told the gradient, so I need to do that first. So remember the gradient is y2 minus y1 over x2 minus x1. So I call that x1 and y1, and this one x2 and y2. So that gives me 3 minus 7 all over minus 1, minus 1. 3 minus 7 is minus 4, and minus 1 is minus 2. A minus divided by a minus is a plus, and 2 goes into 4 twice. So I've now got that. And now I pick a point for it to be A and B. It doesn't matter which one I pick. So I'll pick the one with no negatives because it's just easier to work with, or you might pick the one with smaller numbers. It's up to you. But you get y minus b is mx minus a. Subbing in my numbers, y minus 7 then equals m, which is my 2, x minus 1. Expand the bracket. I get 2x minus 2. So y is 2x. And take away 2, but I need to add 7 because the opposite of take away is add. So 7 take away 2 is 5, plus 5. And I'm done there. Okay, example 6. Find the equation of a straight line through minus 2, 5 and 2 minus 1. So again, I need the gradient first. So that's x1, y1, x2, y2. Gradient y2 minus y1, x2 minus x1, minus 1 minus 5 then, all over 2 minus minus 2. Minus 1 take away 5 is minus 6. 2 take away minus 2 is 4 because I need to add. And then always simplify your fractions. Minus 3 over 2. So now I can pick a point to be A and B. I'm just going to pick the second one, but you can pick the first one. Y minus B minus minus 1 equals gradient minus 3 halves x minus 2. Tidying that up before I do anything, y plus 1 then, minus 3 halves x minus 2. Move the 2 to join the y plus 1, so put that in brackets. Leave the minus 3 and x minus 2. Expand the brackets, 2y plus 2 is 3x, well minus 3x, and watch your minuses. A minus 3 times a minus 2 is a plus 6. And then leaving it in any form you like. Again, I'm just going to move the 3x over, so that becomes positive 3x because it's minus, plus 2y, and I'll just move the 2, minus 2 makes 4. that's fine, or 3x plus 2y minus 4 equals 0. Since we've not needed any other information from this question, I'm done there. Note that you've seen this from a gradient video, vertical and horizontal lines. If I've got a horizontal line, it's got a gradient of 0. Now, what would happen with points there? It would mean that your points would be something like this. If I just pick 2 points. If I had like 3, 1, then, and I also had something like 7, 1, then if you did the gradient, you would have 1 minus 1 is 0 on the top. So what would the equation of a line be? Well, the equation of a horizontal line is just, since the y is always the same, y equals a number. So in this case, y equals 1 would be the equation of that line. Similarly with vertical lines, if you do a vertical line, if I picked a couple of points on a vertical line, let's say something like 3, 1 again, but this time we're going to say 3 and 8. If you do the gradient on that, and check my gradient video if you need help on this, you get y2 minus y1 is 7 over 3 minus 3, which is 0. Now you can't divide by 0, so the gradient is undefined. Now when the gradient is undefined, notice the x coordinates are the same, they're always going to be the same, so the equation of this line is x equals a number. The equation of a vertical line is x equals a number, the equation of a horizontal line is y equals a number. Okay, let's look at the equation of straight line from graphs. Now, the graphs are usually scatter graphs, but they don't have to be. It can just be any graph in context, but they all work exactly the same way. You're given a graph, you're given a straight line, and you need to find 2 points to find the gradient. And then once you've got the gradient, y minus b is mx minus a. The only difference at the end is, often, this y is not a y and this x is not an x. It's often something else, like an a and a b, or a c and a d, and you need to sub in that to change the axes. But let's just do one where it is y and x. So I've got this line here, and I need to find 2 points. So I just look, zooming in, I can see I've got this point here. So let's just take a note of that one. That's along 2 and up 3. And I can see another point on the line there. That's along 9 and up 7. So now I've got my 2 points. I can find the equation of a straight line. x1, y1, and x2, y2. Gradient 7 minus 3 over 9 minus 2. 7 minus 3 is 4. 9 minus 2 is 7. So my gradient of this line is 4/7. So now I can do y minus b is mx minus a. I'll just pick the point a and b to be 2 and 3. Let me just check I've done that right. 2, 3, 9, 7. 7 minus 3 is 4. 9 minus 2 is 7. Yes. So y minus b equals m x minus a. Taking the 7 up. 4x minus 2. 7y minus 21 equals 4x minus 8. And that gives me 7y. I'll move the 4x over. And I'll move the 21 to join the 8. So 21 minus 8 is 13. And that would be a fine way to leave it. Or you could leave it as minus 4x plus 7y minus 13 equals 0. And sometimes you'll want it as y equals mx plus c. So I'm just going to show you that. Moving it, looking at this minus 4x plus 7y, if I put the x back, I've got 4x plus 13. Dividing by 7 then, you get 4/7 of x plus 13 over 7. And you would just leave it like that if you wanted it as mx plus c. Example 2 for equations of straight lines from graphs. I've got this graph here, but this time it says q and p. So not y and x, but that's okay, because I just put it as q and p at the end. And it says find the equation of a line of best fit in its simplest form. Use your answer to part A to estimate q when p is 4. Find the value of p when q is 3. So we'll get to b and c in a minute. Let's just find this equation. So we need a point. So we've got 3, 9. We need another point. So I need to pick one on the graph where I can read. So always in the corner, 5, 4. So now my gradient is, I'll just call that x1, y1, and that one x2, y2. y2 minus y1 is 4 minus 9. x2 minus x1 is 5 minus 3. 4 minus 9, watch your negative numbers here, is minus 5. And 5 minus 3 is 2. So you get minus 5 over 2 as our gradient. Now y minus b is mx minus a. So I'll pick my a and b to be 3 and 9. You can pick 5 and 4 if you want. y minus 9 equals minus 5 halves, x minus 3. Taking the 2 up, y minus 9 is minus 5x minus 3. 2y minus 18 is minus 5x. 5 3s are plus 15. Again, doing the same trick as I usually do, x and y together. So I've got 5x plus 2y, and I'm moving the minus 18, so it becomes plus 18. 18 plus 15 is 33. But if I stopped there, I'd be wrong, because it was in terms of q and p. So x is actually p, and y is actually q. So to finally finish this, I say 5p plus 2q equals 33. Now, usually with these questions, you're going to leave it as y equals, or in this case, q equals. So I'm going to do that for part A. So I've got 2q equals minus 5p, just moving it over, plus 33. So q equals minus 5 halves of p plus 33 over 2, and I'm done there. Now part B. Use your answer to part A to estimate the value of q when p is 4. So p is equal to 4. So I take my equation, which is why I've written it as q equals. It'll just make it easier to work with. Q equals minus 5 halves of p, well, p is 4, plus 33 over 2. So it's just substitution. I need to work out my numbers here. Well, 4 divided by 2 is 2. 2 5s is 10. So it's minus 10. And then 33 over 2, sorry. Well, 2 goes into 3 once. 2 6s is 12. So it's plus 16.5. So that gives me 6.5. And it might have some units usually, but for this question, no. So 6.5. Or 13 over 2 if you prefer. Question C says estimate the value of p when q is 3. So again, we're starting off with our basic equation, and q is becoming 3. So that means my left-hand side is 3. I've got my right-hand side. Now this one's got lots of fractions in it, but that means I'll just need to get rid of the fractions. So times them by 2 to get 6, minus 5p plus 33. Solving this equation, take away 33 from 6, so that's 16, 26, 7, 8, 9, 30, 1, 2, 3. That's minus 27, I believe, is minus 5p. So then dividing through by minus 5, minus 27 over minus 5 equals p. Now you can't leave it as a minus over a minus, so then you just write p equals 27 over 5. And if that's a simplified fraction, you're done there. Okay, the general equation of a straight line. So I've already mentioned this already, but to tidy this up, if I've got a straight line of equation 3x minus 7y minus 4 equals 0, that's called the general equation of a straight line. It's ax plus by plus c equals 0. X, y, number equals 0, and you can have a number in front of x and y. And we need to find the gradient and where it cuts the y and x axis. Now remember, people make this mistake all the time and think the number in front of x is a gradient and they immediately go 3. No chance, right? It's not 3. And the reason it's not 3 is this. It has to say y equals mx plus c first. M's the number in front of x when it says y equals. So you need to rearrange it first. So that's always going to be a step if you're given an equation where it doesn't say y equals. Rearrange it first to find the gradient. So let's start with A. We've got 3x minus 7y minus 4 equals 0. Well, I'm going to move everything that's not got a y in it to the right-hand side. So leaving the minus 7y alone. 3x is positive because there's no sign in front, so that becomes minus 3x. And minus 4 becomes plus 4. Now I can divide by minus 7. So I've got minus 3 over minus 7x plus 4 over minus 7. Now we never leave in maths minuses on the bottom of fractions or minus divided by minus, so we need to tidy it up a little bit. So that gives me y equals just 3/7 x and minus 4 over 7. Now we can say the gradient is the number in front of x, which is 3/7, and we're done there. Let's go to part B. Find the point of intersection with the y-axis. If it's a y-axis, that means the other letter, x, equals 0, okay? Because if you think of an x and y-axis, up and down the y-axis will not move along the x, so x is 0. So we'll just sub 0 into our equation. Well, actually, if we've written it like this, c is always a number at the end, so we can see it. It's there, minus 4/7. But you can see that if you put 0 in, you get 0 for here, so you get left with minus 4/7. So you get y equals minus 4/7. But we want the point of intersection, so we need an x and a y, so x is 0, minus 4/7 there. And the last part is find the point of intersection with the x-axis. Well, for part C, for the x-axis, if you think about going along the x-axis, I never go up the y-axis, so y is 0. So I sub in 0 for y. Now you can sub it into the equation with loads of fractions in it, or better, to be honest with you, go back to the original question and get rid of the fractions and it'll be easier. So I'm going to use this, 3x minus 7y minus 4 equals 0. Y is 0, so that gives me 3x minus 4, because 7 times nothing is nothing. And that's easy to solve. 3x equals 4, so x is 4 over 3. The point is 4/3 and 0, and we're done there.
On to line of best fit. This is basically a straight line question, but it comes in the stats topic because it uses real world data. So it is all just straight line with a little extra bit on. Let's look at one of the questions. 2014 National 5 Maths, paper 1, question 6 had this one. McGregor's Burger sells fast food. The graph shows the relationship between the amount of fat and the number of calories, fat in calories instead of x and y in other words. Part A, find the equation of a line of best fit. Well, it's just the same as straight line. We need a point and we need the gradient. So let's find the gradient first. Let's see if we're given any points. Way down right at the bottom, it says point A represents 5 grams of fat and 200 calories. And point B represents 25 grams of fat and 500 calories. So our 2 points that we've got are 5 and 200 and 25 and 500. So for question A, to get the equation of a line, well, we need the gradient, which remember is y2 minus y1 over x2 minus x1. So x1, y1, x2, y2. That gives me 500 minus 200 on the top, 25 minus 5 on the bottom. Non-calculator, so that gives us 300 over 20. Well, that gives us 15 as our gradient. And we've got a mark there for getting 300 over 20 or 15. Part B, next part of the question, I always use y minus b equals mx minus a, where a and b is a point. So let's just pick the first point, a and b. You could have picked the other one. Subbing that in, you get y minus 200 equals 15, x minus 5. Tidying that up, so it says y equals. You've got a mark there just for getting this, so you get y minus 200 equals 15x minus 75. 5 15s. Y equals, move the 200 across, 15x plus 125. And usually with a straight line question, you'll be done there. But this is worth 3 marks, and you get a final mark for swapping the y and x for the proper terms. So in this question, y is c for calories and x is f for fat. So I switch the y for c equals 15f plus 125 for my final mark. Let's move on to part B. Part B says a super deluxe sandwich contains 40 grams of fat. Use your answer to A to calculate the calories. So we're just substituting 40 in for F. So for part B, F equals 40. So C equals 15 times 40 plus 125. A little bit of work to do, 15 times 40. So 15 times 40. You've got 0, 4 5s is 20, 4 1s is 4, 5, 6. So C equals 600 plus 125, which is 725 calories. And we're done there.
National 5 Maths 2014, sorry, paper 1, question 8. Find the equation of a line joining these points. So you see a pattern here. Exactly the same again. Find the gradient. x1, y1, x2, y2. So we get 15 minus 5, 3 minus negative 2. That's 10 over 5, which is 2. Equation of a straight line. Y minus b is mx minus a. pick a point. 3 and 15 is the most easiest one because they're both positive. So A is 3, B is 15, y minus 15 is 2x minus 3. Expand the bracket. Y minus 15 is 2x, take away 6. Add 15 to the right-hand side then, because it's negative, so it becomes positive when it moves over. Y equals 2x plus 9. 15 take away 6 is 9. That's 5 maths 2016, paper 1, question 5 on line of best fit. A cattle farmer records the weight of some of his calves. The scatter graph shows the relationship between the age, months, and the weight in kilograms of the calves. So weight up top, age on the side. Line of best fit is shown. Point D is a 3-month-old calf and weighs 100 kilos. Point E is 15 months and 340. Find the equation of a line of best fit. So this is straight line in context, where all we've done is changed that Y to W and X to A. So it's still the same idea. We need to find 2 points to find the gradient. Then use Y equals mx plus C, or Y minus B is mx minus A. I use the second one usually. So there's my point D, there, and E. So let's write down the 2 points to start with. D is 3/100. It tells me here. E is 15/340. That tells me there. So I can find the gradient. Remember, gradient is y2 minus y1 over x2 minus x1. So I call one of them x1 and y1, and the other one x2 and y2. I usually make the bigger one x2, y2. Subbing it in, 340 minus 100 over 15 minus 3. That's 240 on the top and 12 on the bottom. 12 goes into 24 twice, so that makes 20 as my gradient. So now the second step is to use y minus b equals mx minus a. That's the way I always do it, so I'm going to not stop there. A and b is just one of the points, so I always use any one, but the small one's easier. A and b. So a is 3, b is 100. Y minus 100 equals m, which is 20, x minus 3. Expanding my bracket then, y minus 100 equals 20x. 20 times 3 is 60, so minus 60. It says minus 100 on this side, so if I add 100 to the other side, I'll have y on its own. So y equals 20x. 100 minus 60 is plus 40. And usually I've done it with straight line, but now we need to look at what it's telling us in the question. It's w and a. So I write w for y equals 20a for x plus 40, and that's part A done for all our marks. Part B, use your equation for part A to estimate the weight of a 1-year-old calf. So let's see what A and W represented. W is weight in kilograms, age is months. Oh, we're trying to trick us here. 1-year-old means A equals 12 because age is in months. So W equals 20 times 12 plus 40. 20 times 12, well, I'll do 20 times 10 is 200. 20 times 2 is 40, so that gives you 240 plus 40, which is 280 kilograms. And we're done there. 2017, paper 1, question 6. The diagram shows a straight line passing through, joining the points A and B. Find the equation. So we've given the straight line, we've got 2 points. Find the gradient first, y2 minus y1 over x2 minus x1. So I'll call my first point x1, y1, and my second point x2 and y2. Substituting that in and being careful of the signs, we get minus 2 take away 6 on the top and 3 take away negative 1 on the bottom. So that gives us negative 8 over 4, which is again negative 2. Now use the equation of a straight line, y minus b equals mx minus a, where a and b is just any point you want, so pick one of the points. I'll pick 3 and minus 2 in this case. So we've got y minus minus 2 equals minus 2, x minus 3. Watch your signs. Y plus 2 is minus 2x. Take away 6. Plus 6. Minus 2 times minus 3 is plus 6. Watch your signs. Then taking the 2 across to the other side, you get y equals minus 2x plus 4. Taking away 2 from both sides. 2018, paper 1, question 7, a little bit different this one. The cost of a journey with Tom's taxis depends on the distance travelled. The graph shows the cost in pounds. Point A represents 8 miles, £14. Point B is 12 miles and £20. Find the equation of the line in terms of P and D. they'll be put off by the context of this. We're giving you 2 points, so it's just the gradient, and then y minus b equals mx minus a. There's a little adjustment to be made at the end though. So here's our gradient formula. So our first point is 8 and 14. So there's my x1 and y1. And my second point was 12 and 20. So there's my x2 and y2. Substituting that in, you get 20 minus 14 on the top and 12 minus 8. So that gives me 6 over 4. Always simplify fractions. 3 over 2. So that's me got my gradient. So I can now move on and use y minus b equals mx minus a. So there's my gradient. And just pick a point, so any one you want. I'm just going to pick the 8 and the 14, or you could have picked the 12 and the 20. So there's my 8 and 14 for my A and B. So y minus 14 is 3/2 x minus 8. Watch out, we've got a fraction, so I'll times the left-hand side by 2 to give 2 bracket y minus 14 equals 3 bracket x minus 8. Multiplying out both brackets, 2y minus 28 is 3x minus 24. Moving that on further, we've got 2y is 3x plus 4, just by adding 28. And then I want y on its own this time, instead of leaving it as multiples of y. So I get 3 over 2x plus 2 dividing through by 2. Why? Because I want to express my equation in terms of p and d. So this is the last bit you need to watch out for here. You need to swap the y for p and swap the x for d, because the y-axis is p and the x-axis is d. If you don't do that, you lose a mark. So you now get your final answer is p equals 3 over 2d plus 2. And there you go, that's a question in context. Part B said, let's just take it, calculate the cost of a journey of 5 miles. Well, you're going to use your formula. 5 miles, d is 5. So it's 3 over 2 times 5 plus 2. This is non-calculator, so you times by the numerator and divide by the denominator. 3 times 5 is 15, so we get 15 over 2 plus an extra 2. Now 15 divided by 2 is 7.5, plus an extra 2 is 9.5, so it's £9.50. Watch out again, it's 9.5 is the answer, but it's money, so I need 2 decimal places, £9.50.
Line of best fit, SQA National 5 Maths 2019, paper 1 question 6 had this one. It says the fuel consumption of a group of cars is recorded and the scatter graph shows the relationship between the fuel consumption, F on the y-axis, kilometres per litre, and the engine size, E in litres of the cars. The line of best fit is drawn. Find the equation of the line of best fit in terms of F and E. Give your equation in simplest form. And then for part B, engine size 1.1, use your equation to find the kilometres per litre he should expect to get. So part A first, straight line question. We need 2 points to find the gradient, and then y minus b equals mx minus a. Now it's not told us any points here, so we need to go up to the graph and find them ourselves. So you just look for real points on the graph. So don't pick this, that's not on the graph. Don't pick this. Don't pick this that you can't read. Look for one you can read. There's one there, and there's one there. So our first point I'm going to use is this one, and that is looking here 3.54, so it's along 3.5 and up 8. So I can take a note of that here, 3.5 and 8. And similarly, this one here I can see is 1.514. Once you get your 2 points, you can work out your gradient. So remember, gradient is y2 minus y1 over x2 minus x1. So I'll call that x1 and y1, and this one x2 and y2. So we've got 14 take away on top over 1.5 minus 3.5. Now I should be expecting a negative answer here because the slope is sloping down the way. So 14 take away is 6, 1.5 minus 3.5 is minus 2, which gives me a gradient of negative 3. 6 divided by negative 2. Then we're going to use y minus b equals mx minus a. So I'll just call one of the points a and b. Let's do this one, but you can use the other one. So y minus b is mx minus a. So we've got y minus 8 equals minus 3x minus 3.5. Get a mark for getting that far, and then fixing it all up. Y minus 8 equals minus 3x. Minus times a minus is a plus. 3 times 3 is 9, plus 1.5 is 10.5. And then that means y equals minus 3x plus 18.5. But we need to swap our axes for f and e. So f equals minus 3e plus 18.5 for our final mark. Part B says use your equation to work out how many kilometres per litre he gets, which is f, and his engine size is 1.1. So for part B, E equals 1.1. So that means that F equals minus 3 times 1.1 plus 18.5. That equals minus 3.3 plus 18.5. And if you can't do that sum, you can just at the side do 18.5 minus 3.3 to get 2. 8 minus 3 is 5 and 1. So you get 15.2. And the units were given to us, kilometres per litre. Kilometres per litre. And we're done there for our final mark. Find the equation of a line passing through those points and give it in simplest form. So we need the gradient first. So gradient is y2 minus y1 over x2 minus x1. So that's x1, y1. That's x2, y2. So that gives me 7 minus minus 1 on the top. And minus 5 minus minus 3. That gives me 8. Minus 5 add 3 is minus 2. That gives me minus 4. Now we use y minus b equals mx minus a. Or y equals mx plus c. So I'm going to just pick a point for a and b. I'll just pick the second one, a and b. Y minus 7 is minus 4, x minus minus 5. Watch out for minus minuses. Y minus 7 is minus 4, x plus 5. Y minus 7 is minus 4x minus 20. So y equals minus 4x. Minus 20 plus 7 is minus 13. And we're done. National 5 Maths 2023, Paper 1, Question 7. A business records sales of a sample of its employees in the length of time they worked for the business. The scatter graph shows the relationship between their salary and the time and years they worked. The line of best fit is shown, so it's a straight line question. Find the equation of a line of best fit in terms of P and T. Give the equation its simplest form. So to find the equation of a line, you need to find the gradient, and then you need to use the formula y equals mx plus c, or y minus b equals mx minus a. So I need the points for gradient, so let's pick some points. There's one clearly there. That is 5 to 1,000. 20,000, sorry. And the second point we can pick is clearly identified here, which is 25, 50,000. So starting off with our gradient, y2 minus y1, x2 minus x1, that's x1, y1, that's x2, y2. So that gives me 50,000 minus 20,000 divided by 25 minus 5. So that's 30,000 on the top divided by 20 on the bottom. Quite a big number to deal with, but we can get rid of the zeros to start with. And that gives me 3,000 divided by 2, which is 1,500 or 1,500. So there's our gradient. So now we can do y minus b equals mx minus a is how I usually do it, or y equals mx plus c if you prefer. So there's our straight line, and I'm going to use the point A and B, positive numbers, so nice and straightforward. Y minus 20,000 equals 1,500 times x minus 5. Don't be worried about the big numbers because it ends in zeros, so we can deal with that. So that's y minus 20,000 equals 1,500x. And we need to do 5 times 1,500. So 5 15s is 75. So minus 7,500.
adding 20,000 to both sides, we get 1,500x. 20,000 minus 7,500 is 12,500. So there we go in terms of y and x. But our graph is in terms of p and t, p and time. So we need to change the y-axis to p equals 1,500t plus 12500. Just make sure it's a capital T. It is. So we're done there. Part B, use your equation from Part A to estimate the salary of an employee who has worked for the business for 8 years. So remember, our P was 1,500t plus 12,500. And they're saying that 8 years, so that means that the pay is 1,500, time is 8, plus 12,500. Okay, 8 times 1,500, so if I double it, I get 3,000, double again 6, double again 12, so I get 12,000 plus 12,500, which is equal to, with a pound sign, £24,500. Let's see if that agrees with the graph. That looks about right, so we're done.
SQA National 5 Maths 2024, Paper 1, Question 9. In a car rally, competitors start at different times. Scatter graph shows the relationship between the length of time they have been driving in T minutes and the distance in kilometres to the finishing line. A line of best fit is drawn. Point A represents 3 minutes and 26, so that's 3:26. I'll take a note of that. Point B represents 10 minutes and 12 kilometres. 10 minutes and 12 kilometres. Find the equation of a line of best fit in terms of D and T. Okay, so it's an equation of a line, so I need the gradient, which is y2 minus y1, x2 minus x1. So I'll just call the first point x1 and y1, and the second point x2 and y2, or the other way around. So I've got 12 minus 26, just watch out for minuses, over 10 minus 3. And I'm expecting a negative answer because it's sloping down the way. So 12 minus 26, 12, 22, 23, 24, 25, 6 is 14. So I've got minus 14 all over 3. 10 minus 3 is 7. That is minus 2. And now the equation I use is always y minus b equals mx minus a. You might have been taught to use y equals mx plus c, but you'll get the same answer. So I'll pick one of the points to be a and b. It doesn't matter which, so I'll just pick the 10 and the 12. Y minus 12 equals minus 2x minus 10. Y minus 12 equals minus 2x, and a minus times a minus is a plus. Watch out, plus 20. So y equals minus 2x, 20 minus 12, so I'll add 12 is 32 plus 32. And I'd usually be done there, except the axes is not x and y, is d and t. So y becomes d, d equals minus 2. Is that a big T? Yeah, it is. T plus 32, and that's my final answer, and we're done there. Another competitor has been driving for 7 minutes. Use the equation to estimate the distance the competitor is from the finishing line. So I've got D, remember, is minus 2t plus 32, and they're telling me that t equals 7. So that means that D equals minus 2 times 7 plus 32. That's minus 14 plus 32. So I need to do 32 minus 14. So 24, 25, 26, 28, 29, 30, 31, 32, 18. 18 kilometres. Get your units in there. That is kilometres, isn't it? That's the 5 Maths 2014 Paper 1 Question 11 says a straight line has the equation 4x plus 3y equals 12. Find the gradient of the line. Well, that's quite easy then. So we just rearrange it to make y the subject. So we've got 4x plus 3y equals 12. So taking the 4x over to the other side, we get minus 4x plus 12. Dividing through by 3, we get minus 4 over 3x, plus 12 divided by 3 is 4, and then stating our gradient, m must equal minus 4/3. And we're done there. Part B says find the coordinates of a point where the line crosses the Part B says find the coordinates where a point crosses the x-axis. So we've got 4x plus 3y equals 12, remember. Cuts the x-axis when y is 0. So we've got 4x plus 3 times 0 equals 12. So 4x equals 12. So x is 12 divided by 4, which is 3. So the point is 3, 0, x and y. SQA National 5 Maths 2017, Paper 2, Question 11. A straight line has equation 3x minus 5y minus 10 equals 0. Find the gradient of this line. So to find the gradient of a line, we're either using the gradient formula if we've got points, but we've not got points, or we're rearranging in the form y equals mx plus c. mx plus c. So we need to make it look like this because then m is the number, the gradient, which is the number in front of x, when it's in this form. So let's start off with our equation. 3x minus 5y minus 10 equals 0. So moving everything over to the right-hand side, it hasn't got a y in it, so leaving the minus 5y alone, that gives me minus 3x, because it's positive on this side, and then plus 10, because negative becomes positive when you move it over. Now we need to divide by minus 5. So dividing by minus 5, we'll get minus 3 over minus 5x, plus 10 over minus 5. Simplifying that, minus divided by minus is a plus, so I'll just leave that as 3/5 of x. And 10 divided by minus 5 is minus 2. So I now know that my gradient to answer the question equals simply 3/5. And we're done there.
So 5 Maths for 18, Paper 2, Question 14 on a straight line. A straight line has this equation, 2x minus 5y equals 20. Find the coordinates of the point where the line crosses the y-axis. Cuts the y-axis when x equals 0, the opposite. So y-axis when x equals 0. So I'll just sub it straight in. There's no need to rearrange here. When x equals 0, I've got 2 times 0 minus 5y equals 20. So that's minus 5y equals 20. Divided by minus 5, y is minus 4. So to put my coordinate, that as a coordinate, remember x and y, x is 0, y is minus 4, and I'm done there.
SQA National 5 Maths 2024, Paper 1, Question 11. A straight line has an equation x plus 4y minus 24 equals 0. Find the gradient. The gradient is the number in front of x, but only when it says y equals, so I need to rearrange. So I'll keep the 4y where it is. I'll just move that x, so that's positive, so I'll make it negative x on the right, and minus 24 is plus 24. And now I can divide everything by 4, so I get minus a quarter x. 4 5s are 24, 6s are 24, and that means the gradient, I'll write gradient, I suppose, which equals m, is minus 1/4. And we're done there.
This has been Mr. Clelland for Maths. Today we went through the whole of straight line and National 5 Maths. Hope you found that useful. Give it a like and subscribe. Take care, stay safe, and goodbye.